So looking at note 7.6, we're looking at exponential functions. How do I evaluate and graph an exponential function? So the first thing we want to review is what is a linear function. So if we look at linear function here, and I gave you an example, we have y equals mx plus b. What's going to happen if you have a linear function? You're going to have a straight line when you're looking at the graph. And then if you look at a table, and again, this should be a review of linear straight lines. If you look at your table, we can see that our x values are increasing by 1. And we can see that our y values have an increase of 2 each time. And so they have a constant rate of change. We are increasing by a constant number for your x's and your y's. When that increase, or it could be a decrease, is either being added or subtracted, you're going to have a linear equation. So I wanted to review linear. Let's take a look at what exponential looks like. When we have an exponential equation, the variable, let's write this down, the variable is the exponent. The variable is the exponent. So we're going to have to the power of x, the letter. And I gave you a general equation here, y equals, general formula, a times b to the power of x. So let's look at the table and see what happens in this table, because it is different than if it was a linear equation. My x's are increasing by a positive 1 each time. But take a look at what's happening with the y values. As we increase each time, we're actually multiplying by 3. So we go from 1 times 3 is 3, and then 3 times 3 gets you the 9, and 9 times 3 gets you the 27, and the 27 times 3 gets you the 81. So when it is exponential, we're either going to be multiplying or dividing. That's what our increase is going to look like, or our decrease. And just to sketch what a graph would look like here, it's going to have kind of a curved line to it. I'm just sketching kind of a general idea of what it's going to be like. So in this lesson, we really just want to look at graphing one of these. So we're going to graph one on the next slide. And I cannot stress enough, exponential equation means that the actual letter, the variable, is the exponent. And that's it. We're just making a table. That's it. So whenever we make a table, you get to pick values for your x. I always like to pick a negative and a 0 and a positive. And so we are going to plug those values in for our x. So here's our equation, y equals 3x. So if I plug in negative 1, I'm going to have y equals 3 to the power of negative 1. Well, back to a negative exponent, we know that that really means 1/3. Or if we want to change it to a decimal, 0.3 repeated. Or use your calculator and type it in. Plug in 0. We know anything to the 0 power, y equals 3 to the 0 is going to be the whole number 1. And plug in a positive 1. Y equals 3 to the power of 1. And we know that's just a whole number 3. And we look at the next one. We plug in y equals 3 squared. And 3 times 3 is 9. And last but not least, we plug in that 3 and we're going to get 27. And so to graph this, you're going to start to see that curve. I'm going to go back on my x value to negative 1. And I counted by 3s, but we're barely going to be off the line because it's a decimal of 0.333 repeated. And we're still barely off the line when we're at 0 because we're only at 1. And then we're over 1 and we're up 3. And then we're 2 and we're up 9. And then look what happens when we get over to the 3. We shoot all the way up really high to the positive 27. So you can see this curve that is occurring. This is an example of what the graph is going to look like for an exponential equation.